Okay, now let's look at type 2 binary ionic compound. In order to be able to do this one successfully, guys, you must use your periodic table I showed you. Remember, type 2 binary ionic compounds contain metals that have more than one charge. So if you look at the periodic table I gave you, okay, remember, look at the charges. If it has more than one charge, it is a type 2. And type 2 means that you must use Roman numerals. So when you look at your periodic table, if you're using an element that has more than one charge, you must use Roman numerals. Okay? So, let's go back to our page here. Okay, let's do some examples. Let's look at first, there's only two elements with binary. First element is a metal, it's iron. I look at its charges, it has a +2 and a +3 charge. There we go. It is type 2. You're going to have to use Roman numerals. So let's figure out which one of these two charges I'm using first. So I look at oxygen's charge. Oxygen has a -2. Check the charges for oxygen. Does this 2 match this 2 down here? Yes, it does. So if these two match, then whatever is down here is a charge I will give to iron. I do not need the other charge. And I would name this iron 1, 2, 3. What's the charge I chose? Oxide. Iron 3 oxide. Let's try another one. Let's do CuCl. Okay? Binary, 2 elements. Copper is a metal. Okay? Look up its charges. It's +1 and +2. Fluorine has a charge of -1. Does this 1 match this number down here? Yes, it does. It's a 1 to 1. If these two match, then whatever's down here is the one I'm going to choose. I'm not going to use the 2. So I name this copper 1 fluoride. Even if it's a 1, you have to use the Roman numeral to tell me. Okay? Now, what if they don't match? What if I did something like this? W N Q. Let's look at that. Okay? So, I look at this, I say, okay, this is tungsten, it's a metal. It has the charges. Oh my goodness, what charges does it have? Well, it has 2, 3, 4, 6, and 7. I do believe. I can't get back to my periodic table, but check yours. Okay? Nitrogen, I know, has a -3. So I check my work here. Does this 3 match this number here? No, it doesn't. It doesn't at all. This is a 1. This had to be W3 at one point in time. Well, go from 1 to 3, I had to multiply it by 3, right? What I do to one side, I have to do together. This would be then in 6. That -3 now matches this 3 here. So whatever's down here has to be up here, +6. Is that one of my choices? Yes, it is. So I would name this, it's over here, tungsten 6 nitride. Okay? Take a look at it for a minute. And make sure you can see what I did. I'm going to give you one to try. Let's try this. Let's do give you a few minutes to try that. Turn off the pause the PowerPoint and then come back to it. Okay. So now it's tin and oxygen. Tin has charges of +2 and 4. Oxygen has a charge of minus 2. Does this 2 match this number down here? No, it does not. So I know at one point in time it had to be S in 2. Oh, what? Well, it's a 1 to 2 ratio, so 2 to 4. 1 times 2 is 2. 2 times 2 is 4. Now does this 2 here match this 2 there? Yes, it does. So this 4 has to be going up here. Is that one of my choices? Yes, it is. So this would be 10, 4, oxide. I hope you got that. Now let's go from the name to a formula. What if I give you, let's see, mercury, 1, sulfide. Well, mercury symbol is Hg. It has a charge of plus 1. How do I know that? This 1 right here is what goes there. Sulfide goes back to sulfur, the minus 2 charge. I crisscross them down, that 2 comes down there, that 1 comes down there, and I get Hg2S is my formula. Make sense? I hope so. Go on now to your polyatomic.